Good morning, Math 10C. I've got two parts to today's lesson for you. If you remember from yesterday, we had left off in the back of our booklet, the review booklet for Math 9 on polynomials. And so I'm working through the outcome multiplying and dividing polynomials with you today, and then we're going to jump into some new stuff. It's going to look very, very similar to what we're doing today. And so we're going to be first completing a few questions on multiplying polynomials at the grade 9 level, and then we're going to go to polynomial operations lesson number 2, multiplying a polynomial by a monomial. And so at any point through this video, feel free to pause. And when I do ask you to pause, I am expecting you to be working with a group or however you're instructed to complete the question. Okay, so number 9 draws me a picture. So a rectangle, I see the rectangle has a length that is composed of a 4x and a 7 and a width of 2x, and then inside the rectangles I see the area, which would be length times width. So in the first smaller rectangle, 4x times 2x, 4 times 2 gives me 8. X times x gives me x squared. And then in the larger rectangle here, I see a 7 multiplied with a 2x gives me 14x. And so we were asked to write a multiplication sentence modeled by the rectangle. If we put those two rectangles together, we get that 4x plus 7, that was the length across the top, 4x plus 7 multiplies with 2x, and it equals the sum of the areas of the two triangles equals 8x squared plus 14x. And so that would be a multiplication sentence that has been modeled by this rectangle. 4x plus 7 times 2x equals 8x squared plus 14x. If I reverse that, it says write a division sentence modeled by the rectangle. There are actually two. We know that if we take the area, so I'm just going to write down what is area. So area of a rectangle is length times width. And if I asked you for the length, well, that would be the area divided by the width, or similarly, the width would be the area divided by the length. And so there's actually two possible answers, but the area, the sum of the two areas of this rectangle, 8x squared plus 14x, divide by a side, so I'm going to choose 2x, that equals the length, 4x plus 7, or the other side. The second division sentence I can make, 8x squared plus 14x, the area divided by 4x plus 7, that would equal 2x. Okay, so what I'm doing here is taking the area of the rectangle, dividing by one of the dimensions, getting the other dimension, and completing that again, because again, 2x times 4x plus 7, we saw that over here, 2x times 4x plus 7 equals 8x squared plus 14x. So if I divide by either factor, I should get one or the other. Okay, so multiply or divide. This is what I would like to do today. Let's go through D, E, F, and those look like division to me, and I want to deal with division when we get into factoring polynomials. So someone please remind me in about, I don't know, a week's time, be like, hey, you forgot to go back and do the division questions. For right now, I want you to focus on 10, A, B, and C. This is asking you to multiply. So to multiply symbolically, so without algebra tiles, to understand what it means to multiply typically a one-term polynomial or a monomial by another monomial or a binomial. Okay, so -2 multiplies with x squared plus 6. So the -2 is multiplied with a polynomial with two terms. I like to draw arrows. You do this how you wish. That -2 needs to be multiplied with every single term in that polynomial following it. So I have to multiply -2 times x squared and add it to -2 times positive 6. Okay, so I write negative 2 times x squared makes negative 2x squared. Negative 2 times positive 6 is a negative 12, so I'm going to write minus 12. So negative 2x squared minus 12 would be your final answer. If I go down in B, 3x times x plus 7. Again, 3x needs to be multiplied with every term in the polynomial following it. So I use the arrows to kind of do a shortcut, and I would go right to writing the answer, but I'm going to show you exactly what I'm doing. I'm going 3x multiplies with x, and 3x multiplies with a positive 7. So 3x multiplies with the x, 3x multiplies with the plus 7. 3x times x, you guys just learned if you multiply x's, you can visualize them as powers of x. X times x makes x squared, or x1 plus 1 equals 2. So 3x squared. 3x times 7. If you have 3 x's and you have 7 groups of them, now you have 21 of them. And 21x. Okay, so I keep the x with that. 3x times 7. 3 times 7 is 21, and you had 1x. So this would be your final answer. 3x squared plus 21x. If I go down to C, it says 4x squared times 8. It doesn't matter that the x squared is there. It's a monomial times a monomial. The numbers multiply together, and if I had x terms, I would multiply the x terms and increase the exponent, but I don't. So I'm going 4 times 8 is 32 x squared. Picture it as x squared times 1, 32 x squared. So 4x squared times 8 is 32x squared. Okay. So with that in mind, I want to move into multiplying a monomial with other polynomials. This is going to take polynomials operations, lesson number 2. Okay, so I'm going to switch notes here for you. Take a second now, pause the video, find the page for lesson number 2 in your workbook. So polynomial operations, lesson number 2. When you've got the page number, share it with a friend. I should be able to find the page for you. Here it is. So the second page is 276. That means this is on page 275. Take a moment, find page 275. Okay, and once you've found page 75, let's get started. So using algebra tiles. Now, do we have to use algebra tiles in Math 10C? Not really, but they help us understand or help refresh our memory on why we're doing what we're doing. And so soon enough, the tiles get so big, we can't draw them, and there's too many to draw. It becomes time consuming. We can generalize a strategy for ourselves. So we're going to start with a couple algebra tiles, and then we're going to move into multiplying symbolically only. Okay, so I just want to make the note here because this is a little bit different than Math 9. It's just the publisher's a textbook, nothing special. But shaded tiles in this book represent positive quantities. So I'm going to make myself a note of that. That a shaded square would be a 1. And the shaded rectangle would be x. And then the shaded square would be a positive x squared. And similarly, the white square, small square, would be -1. The white skinny rectangle would be a -x. And then the white square would be a -x squared. So it's just a little bit backwards from how the Provincial Achievement Test and the Math 9 publishers typically do it. So shaded is negative, white is positive. And so it says complete the diagram below to represent the product. Okay, 2 times x plus 1. So I'm looking for the 2 here, 1, 2, both positive, unit squares. And the x plus 1 is down the other side here, making up our second dimension. So the x represented by the shaded rectangle, the skinnier rectangle, and then the unit square for the positive 1. And so we need to multiply 2x, or 2 times x plus 1. And we do that by matching a dimension from each. So I'm looking across the top, I've got 1 times x, and then I fill in the shape. 2, or my second cubed, another 1 times x. I've got a 1 times a 1, or a square dimension, a unit times 1 unit, and another unit square on the bottom there. So that's referring to this length times that width. Okay, and so I haven't gone through and shaded yet, but I do know a negative times a negative makes a positive. Or sorry, this is positive. Positive times positive is positive, and so I'm just going to go through and shade these all positives because it was all positive times positive. So positive times positive is positive, and then I count the algebra tiles in the in my grid here. So I've got 2 x tiles and 2 unit or 1 tiles. So 2x plus 2 would be my answer. If I look at the next one, x times x plus 3. So along the top here, along the length, we could picture it as there's the x tile, the positive x tile. Along the width here, the positive x tile and 3 unit squares, so x plus 3. When we multiply together, we take the dimension from 1, so I've taken the dimension of the x, multiplies with the dimension of the x rectangle, and I draw a larger square in this case. I do that again, I go the dimensions of the length times the width, so an x times 1, x times 1, and then x times 1. Again, these were all positive times positive, so they should be shaded to indicate that they're positive. So we're shading away here. Okay, and then we count them up. I have a large x squared tile and 3 x tiles, so x squared plus 3x. Okay, let's see how we would do this with a negative number. So I've got negative 3 times x minus 1. So I've got 3 negative tiles. That would make up the negative 3, an x tile and a negative 1 tile, so x minus 1. And we go ahead again, we go length times width. Decide what color you're going to shade it. This is the white tile or the negative tile times the positive tile. Negative times positive is negative. I repeat that 3 times. That's a negative 1 times x, negative 1 times x. And then I need to fill in the bottom here. So to complete my rectangle in my grid, I've got a 1 by 1 square, but it was a negative 1 times negative 1. Negative times negative is positive. And I'm going to do that again. Negative 1 times negative 1 is positive 1. Negative 1 times negative 1 is positive 1. And I finish off the question by counting up the rectangles. So I will go and count 3 negative x tiles, so a negative 3x, but 3 positive 1 tiles, so positive 3, negative 3x plus 3. I want you to take a second now, pause the video, pair up with a partner, and work on D and E together. When you have finished, so take about 2 to 3 minutes, finish up D and E, and then I want you to compare your answers to mine. Okay, so let's do that now. Okay, and now that I've brought you back, let's focus on getting the solutions to the bottom here. So I want you to do a comparison. So I'm just going to go along quite quickly. X times x makes an x squared. Positive times positive means I'm going to shade it. X times x makes an x squared. So x times x makes a large square. It's positive times positive, so I'm going to shade it. I've got x times negative 1. Positive times negative makes negative. X times positive 1, also negative because it's a positive times a negative. X times positive 1 and x times negative 1, all 4 negative x tiles. And so when I count this up, I see 2 positive x squareds and 4 negative x's. So compare 2x squared minus 4x. If you got that right, give yourself a check, a happy face, something, let yourself know that you're doing okay with the tiles. And then over on E, I have x times x would make x squared. Positive times positive, so I'm going to shade it. X times x makes x squared. Again, the tiles are the same color, so they're going to be positive. I've got a 1 times x, but the 1 was negative, and the x tile was positive, so this one has to stay negative. 1 times x, where the x tile is negative, from the negative 1 times the positive x. I go ahead, I count them up. 2 x squared tiles and 2 negative x tiles. Okay. And so algebra tiles are a good way to show why we would use or build ourselves into the distribution property. And I hope you're seeing that in some of the answers here, that if you had drawn the arrows and if you had multiplied each term, you would end up with the same thing. Okay, and so as part of this video, I'm actually going to choose not to do class example number 2, just because I really do want to spend the time building the symbolic method with you. And so our work on the front, our investigation with the algebra tiles is enough for me, because this is the important stuff. The distributive property, so it says flip back to class example 1, that was our algebra tiles. Take your answers from A, B, there's C, D, and E, and write down your answers. So I'm just going to copy 2 times x plus 1, we got 2x plus 2. X times x plus 3, that was the answer for B. We got x squared plus 3x. 2x times x minus 2 was the answer in D. We got 2x squared minus 4x. Negative 3 times x minus 1 was our answer in C. It equaled a negative 3x plus 3. And then our very last one, x minus 1 times 2x was our answer in E. We got 2x squared minus 2x. And it says these are examples of a distributive property that an A or some term on the outside of the brackets multiplying with a polynomial, in our case, will be shared with both terms in the bracket or will be multiplied with both terms in the bracket. So A times bracket B plus C means you multiply A with B and then you multiply A with C, and we're always going to be adding them. And if we ever write a subtraction sign, it's because when we multiplied, we actually got a negative. Okay, you can reverse this property. The term with the brackets can go in front. It still means the exact same thing. And so it says use the distributive property to determine the following product. So I go through, I draw arrows. I will also show you the method they're using up here, A times B, A times C, and we're going to build this up so that it becomes so easy for us that we can just do it almost in our heads. So I'm thinking 4 times 3x, 4 times positive 1, because the question was 4 times 3x plus 1. So 4 times 3x, let's write that out, plus 4 times 1. And then it asked me determine the product. Okay, so I'm going to simplify that a little bit. 4 times 3x is 12x. 4 times 1 is 4. And so my answer to that question, 12x plus 4. In B, negative 5 times 2x squared plus x minus 6. The negative 5 needs to be shared or distributed with every term in that trinomial. If I write it the long way, negative 5 times 2x squared, I'm going to write over top of c here for a second. Negative 5 times a positive x, and negative 5 times negative 6. I go through, I multiply out. Negative 5 times 2x squared, well, negative 5 times 2 is a negative 10. That makes negative 10x squared. Negative 5 times positive 1x. Negative 5 times positive 1 is negative 5 with the x. And then negative 5 times negative 6 makes the positive 30. Okay, and so I'm going to keep going to c, asking me to multiply x cubed minus 2 with x squared. I'm going to go above the question. X cubed needs to get multiplied with x squared, and the negative 2 needs to get multiplied with x squared. So I've got x cubed times x squared plus a negative 2 times x squared. And if I simplify this, x cubed times x squared, when we multiply powers of x, we add the exponents. 3 plus 2 is 5. And then negative 2 times x squared will be a negative 2x squared. Okay, we can throw any letter we want in there. The distributive property is the same. We draw our arrows, we would share it out, and we would multiply in steps. So negative 3x multiplies with 7x minus 2y plus z. Well, I'm going to break that up. That tells me negative 3x first multiplies with 7x. Then I add to it negative 3x times negative 2y. And then I add to it negative 3x times z. And the only thing I'm noticing, I have different letters. So wherever I have different letters, I'm just going to write them side by side. Negative 3x times 7x. Negative 3 times 7 is negative 21. X times x is x squared. They can be multiplied together. Negative 3x times negative 2y. Negative 3 times negative 2 is positive 6. And then I've got an x and a y. Okay, I can't put them together because I don't know what they are. It has to stay as x times y until I know what numbers they stand for. And then negative 3x times z, negative 3x times z. So negative 3x z. And it says, in this process, what we have been doing is we've been expanding the polynomial using the distribution or distributive property. You're going to see this word expand when they're implying that you should multiply. So they might not say multiply and simplify as in class example 3 or class example 4. They're going to say expand and simplify. That means multiply. And they're saying when you have used that distributive property, you're essentially using that exponent rule that says x to the 1 times x to the 1 equals x 1 plus 1, or x squared. Okay. And you can also visualize it as a square with dimensions x times x. It makes the x squared large square. Simplify, or expand and simplify. 6 minus 4 times 8x plus 1. So expand means carry out the multiplication first. This out here, the 6, that's not a multiplication. This is saying 6 subtract, then a multiplication statement. So let's do the multiplication first. 4, or I can picture it as a negative 4, multiplies with 8x. Negative 4 multiplies with positive 1. So I would write 6, and then at minus 4, I'm using it, or visualizing it as a negative 4. Negative 4 times 8x. Negative 4 times 8 is negative 32x. Negative 4 times positive 1. Negative 4 times positive 1 is negative 4. And then simplify means collect like terms. A 6 and a negative 4 can go together. They make a 2, and I still have my minus 32x. And so I'm sure some of us are wondering, well, why is she treating the subtraction sign as a negative? I do have a reason. It does cut down your work, because if I was to do the subtraction, I would have to open a bracket here, and do the multiplication of the positive 4, and then the positive 4 with the positive 1, and with the 8x as well. And so I really don't want to do that. I want to indicate subtraction, and so I'm skipping that step where I have to then change the sign or share out the subtraction sign by just assuming that the subtraction sign implies a negative 4, and you will always get the same answer. Okay, so I'm going to do that again on this one just so we can see. It says expand and simplify. Feel free to write across C because we're not going to do that one. Let's just keep working at what we are doing, and we need the room. So 4 is multiplied with 2x minus 3, and we subtract from it 2 times x minus 6. Now I'm going to make that assumption that subtract 2, I'm using it as a negative 2. You're going to see that in my multiplication. 4 times 2x, 4 times 2x, 4 times 2 is 8, need an x. 4 times negative 3, 4 times the negative 3 is negative 12. Now, picturing it as a minus 2, as a negative 2, this is saying multiply negative 2 with x, multiply negative 2 with negative 6. And instead of doing subtract the positive 2 times the polynomial, I'm going to save myself a step. So negative 2 times x, negative 2x, negative 2 times negative 6 is positive 12. I go look across my terms, an 8x and a negative 2x, that will simplify to 6x, negative 12 and positive 12 go to 0. I could write plus 0, but that takes up space, and we want to be neat, concise in our mathematics and in our solution, so we're going to leave it at 6x. Okay. Determine a simplified expression for the area of the given shape by first adding the areas of 2 rectangles and subtracting the areas of 2 rectangles. So if I asked you to find the area of the shape by dividing it into 2 rectangles, we would have to first break it up. And so I want to focus on the adding here because I visualize this as 2 rectangles, one small one and one large one. And so I'm going to take the area of this rectangle and then I'm adding to it the area of this rectangle. And so first things I have to do, I'm just going to go ahead and label. I've got 3x plus 2 all the way from here to here. So I need to know what dimension this is. Okay, so the whole thing is 3x minus 2. Here's the image. That whole thing is 3x plus 2. And then from here to here is x plus 5. So a portion of it includes x plus 5. And I want to know what is like this piece right here, because that's going to match my dimension up here. And so I'm going to get that by going 3x plus 2 subtract x plus 5. I can put it in brackets if you'd like. 3x plus 2 subtract x plus 5. We're going to have to subtract each term. So I'm going to get 3x plus 2 subtract x, subtract a positive 5. Got to collect my terms. 3x minus x makes 2x. 2 minus 5 is minus 3. So this little piece is actually 2x minus 3. And feel free to write all over the space here because we're going to do one version of this question rather than 2. And so if I want to add up the areas, I'm going to add up the area of the first rectangle, I'm labeling it 1, and the area of the second rectangle, labeling it rectangle 2. And so the area of the first rectangle is length 2x minus 3 times width 2x. And the second rectangle is, again, x plus 5, because I don't want to take the 3x plus 2. That was the whole thing. I just want the distance from this corner to this corner to match up here. X plus 5 times 4x. So here's my operation or my multiplication statement with the addition of the 2 rectangles. to now work symbolically to find out what is actually the area of that entire shape by adding the areas of each rectangle. And so I'm going to do this symbolically with the arrows. I'm going to go 2x times 2x is 4x squared. Negative 3 times 2x is negative 6x, because negative 3 times 2 is negative 6. And then I go, okay, you're adding to this, and here's a second multiplication or a second expansion I need to do. I need to expand this. X times 4x is 4x squared. 5 times 4x is 20x. I go through, I collect like terms if I can. I've got 4x squared and 4x squared. I'm going to put that together. That becomes 8x squared. Negative 6x plus 20x is negative 6 plus 20, positive 14x. And so this would be my final answer. If I had gone ahead and subtracted the area of the two rectangles, I'm going to let you figure that out. How would you draw a very large rectangle and then subtract from it the area of a smaller rectangle and get the same answer? So I'm going to leave that up to you. I'm going to leave that as a challenge if you would like it. If not, I'm going to leave some assignment questions in the subplans, and please get started on your homework. All right, I will see you guys after the long weekends.